Hello, statistical scholars. Today we shall search for the truth in our review. Okay, so we're going to do some true or false questions, which once again, I'm probably not going to write much, but here we go. So in a 2010 survey, poll, 70% of the 119 respondents between the ages of 18 and 34 said they would vote into the 2010 general election for Prop 19, which would change California law to legalize marijuana and allow for it to be regulated and taxed. In a 95% confidence interval, the sample had a 8% margin of error. Based on this information, determine the following statements as true or false, and then explain your reasoning. I'm going to zoom in a little bit so we can see this. This first statement is, we are 95% confident that between 62 and 78% of California voters in this sample support Prop 19. Now, here's where this has a problem. In this sample, confidence intervals are about estimating the true proportion for the population, not the sample. So if this one word, sample, was removed, this would be true. But it is not. It is false. Once again, false, false, false. Big time falsies. Okay, so moving on to B. This says that we are 95% confident that between 62 and 78% of all California voters voted between the ages of 18 and 34, support Prop 18. This one is absolutely true. It's exactly how you should interpret this. And if you're wondering where they're getting the 62 and 78 from, you are taking the margin of error and adding and subtracting it from the proportion from the sample, which is exactly how you should calculate a confidence interval. All right, moving on to C. If we consider many random samples of the 119 California voters between, many random samples? Repeated sampling. I wonder what this sounds like. Between the ages of 18 and 34, we calculate 95% confidence interval for each. 95% of them will include the true population proportion of the 18, I keep saying 19, 18 to 34-year-olds in California who support Prop 18. This is exactly what confidence level is all about, that 95% of the time you shall select the true proportion as you repeatedly sample, regardless of what sample you choose, which is what that 95% is all about. So this is exactly what the 95% are about. So this is definitely the truth. Anyway, here's one that might give you a little bit of a loop. In order to decrease the margin of error to 4%, we would need to quadruple, as in multiply by 4, the sample size. The real reason why this is happening, and I'm going to go to my notepad to do this. Let's make sure it's still... Oh no. Where did my recording go? Sorry about that. Oh, it's still working. We're good. Notepad. I'm still on problem 13. All right, untitled page. So when you're looking at margin of error, remember, you have the z-star, right? And then you have the standard deviation and then the sample size. So as you're looking at these two are going to stay the same. However, if you want your margin of error to decrease by half, you need to get a half in here somehow, right? And this is square rooted, so I want to halve my original. And these are staying the same, so we're not changing those. It's only the sample size we're going to change. Now we're going to solve this. So if you're looking at the root and thinking I got to get rid of that, you'd be cool. Or we can just invert our fractions and get that 2 is equal to the square root of n. And then we'll square both sides and get that, yes, it's 4, so we need to quadruple. If you're worried about how I got from here to here, I just reciprocated. Which is also a fun word. Reciprocate, and you shall be saved. Oh god, that was bad. Oh, so was the old god bit. Okay, anyway, I hope we get the point here. Back we go. Where am I? Yeah. It is quadruple. Oh, this is true! Haha! Fun times. 4 times the sample size. Good times. Alright. Another way you go about this is you could do 4 times n into your sample and see what happens. Oh, let's just show you that real quick, since we're only at like 3 minutes. So, alternatively, if this confused you, you could have been like, oh, does that work? You know? If I kept my z the same, and my s the same, and then my square root of n, is this going to be 4 times if I do 4 times the sample? Or is it going to be half if I do 4 times the sample size? So we kept those the same, and then replaced my n with 4 times as much. Well, then that would be, I still have z, and then s, and then 4 times as much. That's the same as the square root of 4 times the square root of n, which would be z times s over 2, because that's the square root of 4, square root of n, which would be a half times you know, what my normal margin of error would be. There's another way to make sense of it. Hopefully maybe that helps. Fun times. Either way, definitely truth. Truth. Veritas, which is the search for the truth in Latin. Fun times. And Latin in the middle for no reason. Okay, last but not leastly, and slightly more beastly, based on this confidence interval, there is sufficient evidence to conclude that a majority of California voters between the ages of 18 and 34 support Prop 19. Well, this is true because, now here you need to be careful, the confidence interval, if you look at it, is between, where's the truth one? There it is. Between 65 and 78, which is definitely more than half because their claim is about, 50%. And clearly my confidence interval is greater than 50% in all values. So you're 95% confident that it's actually larger than 50%. The entire confidence interval is larger than it. All right. That's all she wrote. Or all she said, I guess.